one of the most important things we need to do whenever we start off one of these.
Figure out what the give us.
Yes, sir. And what are we given here?
We're given that angle 2 equals angle 8.
You got it. You got it. So we've got congruent angles. And Kate, what do you notice we're trying to prove?
Later, something.
Thank you. We're trying to prove that, like Jacob said, angles 1 and 8 are supplementary. So, okay. So we've got angle 8 still involved here, and angle 1. Okay. And what are some topics you guys are seeing? Christian, what's one word that jumps out to you between the given and the proven? That's a concept. Yes, sir. Supplementary angles. So we know we're dealing with sup. We know that's going to have to come into play eventually. So I'm thinking we're going to have some supplementary. And Isabella, do you remember another concept that usually goes with supplementary? Yes, ma'am. That's mint-worthy right there. That was a terrible throw. Not bad. Linear pairs. You got it. And why do you think it's important that we know some of these topics we're going to be seeing? Christian, why do you think it's important we're going to know some of these topics that we're going to be seeing? Wait, did I say Christian? And then I looked immediately at Chandler. I don't know. I don't know why I get you all confused. The big thing is, guys, if we know the topics, we know our reasons. Definition, linear pair postulate, things like that. And so I'm going to give you a chance. Take a look at 2 and 3 here. Do these look a little connected to you? Linear pair, supplementary. What are we told straight up, guys? Does that have anything to do with the previous statement? No, it doesn't. So these two are not connected, guys. So if we just have a straight up statement, what are we talking about? Are we talking about a definition, a theorem? Definition, you got it. And in fact, it's going to be the definition of linear pair, straight up. Straight up? I'm sorry. That's trying to be hip with the youth. I'll give you a little spoiler. There's something that almost always comes right after linear pair postulate, 99% of the time. Or, I'm sorry, definition of a linear. Did I just give it away? I just gave it away. Thank you. Isabella, tell us what comes almost always after the definition of a linear pair. Yes, ma'am. The thing I just spoiled. Because once you establish that 1 and 2 are a linear pair, what can we then say linear pairs are also? They're also supplementary angles. And speaking of supplementary, David, what does it mean for two things to be supplementary?
Add up to 180.
Yes, sir. So, David, are steps 3 and 4 connected? If 1 and 2 are supplementary, 1 and 2 add up to 180. And we have words leading to math. Is that going to be a converse? Mackenzie, is this going to be a converse or just a regular definition for step 4? Yes, ma'am, because it's words to math, isn't it? Yep, and these two are connected. So we have definition of sup. By the way, that'll almost always follow after linear pair postulate. These 3 steps are kind of like those annoying siblings you have. They always seem to show up. Immediately, Kate looks over at Jack. Let's go. They always seem to show up together. And what are going to be our last 2 steps here? I bet some of you guys are seeing this. We had 1 plus 2 equals 180. That's math.
Yeah.
It is. You're right. Jack, what did we do here? It looks like we replaced 2 with 8. We substituted. Because what were we told at the beginning, Jacob?
And 2.
So
Yeah.
if 2 equals 8, we can replace 2 with 8 through some substitution. But wait a minute. We've got then math that leads into words. Ugh. So here's the thing. We're thinking converse, aren't we? I heard somebody say it. Converse. I think Isabella and Jack. Of the definition. Christian, did you say it too? I heard that's converse of the definition of supplementary. Now, I'll be real with me, guys. We're at day 7 at this point. How do you feel about doing a problem like this? Is it really stressful? Would you say maybe you knew half the steps? Where are you guys at right now? How about Kate? Where are you at right now as far as maybe knowing steps? Or would you say you knew maybe 20% of these steps, half of them, all of them? Half? Hey, that's great. That's a big start. Because when we first started this, it probably looked like hieroglyphics to you guys. Any other questions? Number 8. Let me fix that camera real quick. So immediately, what are we seeing, Kenzie, as far as what they give us? Yes, ma'am. We're given that right away. So we know angle 4, same thing as angle 5. Now, what are we trying to prove, Angel?
That angle.
So we're trying to prove that this angle is really the same thing as 4 and 5. We're trying to say, hey, if 5 and 4 are congruent, maybe this angle and 4 are also congruent. By the way, what's a concept you guys notice in this picture? What kind of angles are 5 and DCE, Isabella? Yes, ma'am. We got some vertical angles here. So I already know, I'm thinking, okay, vertical angles are going to come into play. We got a theorem about that? We got a few things about that. Yes, ma'am. So let's go ahead and give what they gave us. So we know angle 4 is going to be congruent to angle 5. They just straight up told us that. And here comes the scary part. This is the part that every student in this chapter, you can feel their entire body clench up. What is the next step? That's the scary part. Use what they gave us. Look at what they gave us here. What did we mention earlier about angle 5 and angle DCE? They're congruent because they are vertical angles. Well, were you talking about 4 and 5, Jack?
No, 5.
Oh, 5 and that, yeah, and you're right. We can say that, okay, angle 5 and angle DCE are vertical angles. Absolutely, we can say that. And what lets us say that? By the yeah, thank you, Christian and Isabella. By the definition of vertical angles. We just have a straight up statement. 5 and DCE are vertical angles. Now, is anybody a little confused as to why it wouldn't be the converse because we had math first? Are these two steps connected at all? No, that has to do with angle 4. This is talking about another angle entirely. How about next up, guys? What does that mean if they're vertical angles? Jack said it a second ago. They are congruent. We can say, okay, angle 5 and angle angle 5, let me try again, is equal to angle DCE. You got it? But why? I'll give you a slight break here, Isabella, because you and Christian have been putting in work. I know everybody has, but you guys have done a really good job helping me answer. So why can we now say that 5 and DCE are equal? But what reason, though? Well, guys, aren't we still talking about vertical angles? We had words, then math. I want you to look back for me. Look at our cheat sheet. We have something else besides the definition of a vertical angle. Check it out. Vertical angle theorem. That says that if two angles are vertical angles, which didn't we just state, then their measures are going to be congruent. And here's a little pro tip, Mackenzie. If you have the definition of vertical angles, vertical angle theorem is almost always going to come right after. Because once you say two things are vertical angles, do you think it's important we just go ahead and say that they're equal to each other? Yep. These two, kind of like linear pair postulate and the definition of linear pair, they're connected. So that's a little cheat you guys can use. The vertical angle theorem. Oh, and then what have we done? If we know 4 and 5 are equal, and 4 and DCE are equal, or I'm sorry, 5 and DCE are equal, Jacob, what property lets us cut out the middleman and just go ahead and say that angle DCE, I can't write this morning, is going to be congruent to angle 4? What's going to be able to let us make that final proof? If 4 equals 5, I'm sorry, if 4 equals 5, and we know 5 equals DCE, cut out the middleman. Oh, it's the one that substitution gets confused with a lot. It begins with a T. David, help him out. Transitive. Here's how that works. If we said, hey, 4 equals 5, oh, and 5 equals DCE, then couldn't we say 4 is going to equal DCE? Using a little transitive. All right. As far as day 8 is concerned, I really want to turn you loose right now, and I want to let you guys see if you can actually do a couple of these shorter proofs right here. We've got number 1 and number 2. Oop, wrong number 1. And guys, keep in mind the topic. Angel, what are going to be our 2 topics here on day 8? Linear pairs. Now, Christian, didn't we talk about earlier, if you're talking linear pairs, are there a few things that usually come with that? Definition, linear pair postulate, supplementary angles. We know those 3 are usually connected. So I'm going to let you guys try 1 and 2, and I'm going to be around to help. So let's see what you guys got. Not much of a mystery here. Mackenzie, what do we know after we've established that we have a linear pair, thanks to these 2? What almost always follows? Yeah, guys, if 2 things are a linear pair, they're also supplementary. That just follows. If 2 things are next to each other and add up to 180, 2 things adding up to 180 is the definition of sub. Yes, sir, Jack. Yes. Yep, good question. A postulate is something we assume is true, but we haven't proven it. A theorem is something that has actually been proven is true. Great, great question. Yep, next is substitution. I'm so glad nobody said transitive. Because we don't have enough equal signs in here to be like, okay, this equals that equals that, so that equals that. Instead, we're saying, wait, if 1 equals 2, then if angle 1 plus angle 3 equals 180, that must mean angle 2 plus angle 3 equals 180. That's straight up substitution. Yep. And that's what we wanted to prove all along, that angle 2 plus angle 3, that's really supplementary. Any questions on that one, guys? It looked like most of us were absolutely crushing that one, which is awesome. How about last one on the page here, number 2. Hopefully you guys were feeling pretty good about this one too. Or maybe this one punched you in the face. How about let's go, I'll go rapid fire here. Let's go. Angel, what did you say? If we said 2 and 3 are supplementary, they add up to 180, what would you say that would mean? By what reason?
Are you asking what the
Sure.
definition of supplement?
You guys agree? Definition of sup. I think she's right on. If they're supplementary, they add up to 180. That's actually what we've been talking about up here. Supplementary, they add up to 180. How about Jack? What are you thinking next? 1 and 2 are a linear pair. Ooh, now wait. What usually comes before we establish? Yeah, remember, the definition of a linear pair is what tells us that they are a linear pair. I like where you're going, though. I think you just gave us our next step. Definition of a linear pair, which leads into what, Jacob?
Linear pair postulate.
Yep. So Jack was just one step ahead, like always. See how I turned that into a compliment? Linear pair postulate. Oh, but wait. Normally we then lead into having the definition of supplementary. Is that still going to be the case here? What do you guys think? Absolutely. Because if they're supplementary, what do they add up to be? Yep, that's still true. So guys, it's okay to have the same reasoning 2 times in a problem. That's A-okay. Oh, no. Dang it. Oh, here's the thing. Why is it not going to be substitution? What were we never told up here that we were told in the first one?
The angle. This.
Yes. Look at number 1 in the first one. Were we able to substitute in that angle 2 for angle 1? We can't do that here, can we? They never tell us, hey, this piece is really this. Instead, they tell us, hey, that plus that equals that, and that plus that equals that. Do we see some repetition here? If 2 plus 3 adds up to be 180, and 1 plus 2 adds up to be 180, where's the repetition? What angle shows up twice? 2. So what can we really say, guys? If 2 plus 3 equals 180, and 1 plus 2 equals 180, then angle 1 and angle 3 are really the same thing. Take out the middle, man. That's right, Jack. Preach on it. Let's go. Man, you guys probably almost got that entire thing right. And if you said substitution, you were super close. That's fantastic, guys. That's fantastic. What's up? Yeah, that's great, man. Because this is a little bit of a continuation of day 7. So it's a little bit separate, but we're going to finish up with this, and I'll be done. Let's flip over, and I'm going to let you guys, if you want to partner up with somebody, you are more than welcome to, or you can work solo. And I'm going to see. I'll give you a little hints. Both these next ones deal with bisecting. So we have 2 things that involve bisecting: definition of a bisecting angle and the bisector angle theorem. So keep that in mind, guys. Page 2, we're going to be talking about, our topic's going to be a lot of bisecting. You guys, if you need it, is what kind of angles do we see we kind of have here with like 4 and 3 and maybe 2 and B? Aren't these vertical? So there's your another tool in your toolbox. You can say, wait a minute, I'm probably going to have some vertical angles going on here. Didn't unfreeze? Jack Bruner, what are you thinking for step number 2, my man? Vertical angles? Yes, sir. That is just straight up the definition of vertical angles. Absolutely. Now, Kate, if 3 and 4 are vertical angles, what does that mean about them?
Vertical and material.
Right, but what does that say? Well, that says that if 3 and 4 are vertical angles, then 3 or 4 are going to be. That's right. You were just giving me that backwards, right? Vertical angle theorem. Absolutely. And do you guys see a little repetition in what we found here? David?
Yeah.
We said that 2 equals 3.
Yeah.
What else have we said?
3 equals 4.
Do you see a connection here?
Yes.
If 2 equals 3 and 3 equals 4, what can we then say?
2 equals 4.
Yep, 2 is going to equal 4. Cut out the middleman. 3 is gone. 2 is really equal to 4 thanks to what property? My favorite property. Transitive. Ooh, and then finally, BP bisects ABC. Be very, very careful with this one, guys. I heard somebody say definition of a bisector, of bisecting angles. Be very careful. Look back at what the conclusion is of each of those bisecting ones. I'll pull it up too. Check it. Definition of an angle bisector, that ends with it divides an angle into 2 congruent equal parts. Is that what we're saying here? No, we're saying BP bisects ABC. That's not right. How about the converse? If an angle is divided into two congruent parts, then a line, ray, or plane is an angle bisector. BP bisects ABC. That sounds better. So this isn't a definition. What is this? Well, it is a definition, but it's the converse. I heard Angel mouthing it. We got the converse definition of an angle bisector. All right. Then I'll pause and give you guys a second if you haven't had a chance to do number 4 yet. Oh, that's a power move right there. No? How about, do you guys notice, do we have kind of back-to-back angles here? We have 5, 6, and 7 all adjacent to each other. And what do you guys notice? XYZ is equal to WYV. Wait, do we have angles that have parts? What immediately should come into our mind if we've got parts of angles?
Angle, segment addition postulate.
Angle addition postulate. So I'm thinking, wait a minute, if we have parts of these two angles, then to establish, let's establish something. What makes up angle XYZ? We know XYZ and WVY are equal to each other. What makes up angle XYZ? That's going to be equal to, isn't that 7 plus 6? Yeah, that'd be angle 7 plus angle 6. And we said the reason that is because of, I heard a lot of you say it, angle add post. Well, now, wait a minute. What's angle WYV made up of? What two angles make up? 5 and 6. So angle 5 plus angle 6. And is that the exact same postulate? Angle add post. And I know some of you guys are already seeing now what we're going to be doing. Check it out. Do we have any repetition here? Transitive. Because were we told at the very beginning that this piece equals that piece? So we know that and that are the same. And what else repeats here? 6 and 6. So what does that leave us with? 5's got to be equal to 7. Thanks to the transitive property. Great job, guys. I know that one was a little tricky, but once you saw, wait a minute, this is just part plus part equals whole both times. Yeah, use what they give us. They gave us these two angles and they said, hey, here are the pieces. So that's exactly what we used. Great job, guys. I will wrap up. I'm done. If you have any questions, let me know. Part 2 is going to be online. It should be online actually as of next period.